Hello, everyone, and thank you for joining me on this session today. My name is Samar Akub. I'm a Senior Alliances and Channel Solutions Architect with GitLab. So, how many times you've heard about data leakage or cloud account hacking? Just because the security keys for these accounts were misplaced, misused, or improperly shared. Can we enable our developers to streamline the deployment of their applications and consume the Google Cloud services without sharing, creating, and compromising the security keys for these accounts? Can we really implement a proper split of responsibilities between the admin of the Google Cloud accounts and the developers who are using and deploying their applications to these accounts? This is exactly what we will be discussing in the next few minutes in this session. Well, in our session today, we will tackle three main points. First, we'll see how to minimize the secrets exposure, the risk for secrets or security keys leakage. Second, we'll see how to use that or implement that within the GitLab CI/CD jobs. How can we enable automation jobs to consume Google Cloud services with minimum risk to the security keys? And third, I'll show you how that can be configured on both the Google Cloud and GitLab platform. Sounds exciting, right? Let's go. Well, let's start from the very beginning. Today, for non-human users, applications to consume Google Cloud services, basically similar to what I do for users, where I create a username and password, I do need to create service accounts. These service accounts dictate, based on the roles attached to them, what and how Google Cloud services can be consumed by these applications, non-human users. In order to authenticate and authorize against these service accounts, a security key pair or public-private key pair has to be created. The private part or the public part of the keys is managed inside Google Cloud, while the private key is passed to the end user. So it becomes the responsibility of the developer to manage, rotate, securely control, and store these keys. And they are required by the developer because later they will be used to obtain access token to the cloud services or to the service account, so that the application can consume Google Cloud services, right? So that part where the keys are passed to the developer and they become the responsibility of the end user are the most risky part, because basically I am at some point I may have up to 1,000 different keys for different users, different use cases, right? And things can easily get out of control, and then the high risk can happen. How can we avoid that? How can we eliminate that step in the process? Well, to do so, let's have a look at another concept, another platform, Kubernetes services. Where in Kubernetes, where I can deploy my applications as pods or inside pods, they have the same construct. They have the same Kubernetes service account resource. Service accounts in Kubernetes are meant to be are generated by the Kubernetes APIs as resources, and are meant to be used within the Kubernetes cluster by other Kubernetes resources such as pods. Pods will use these service accounts in the same way to authenticate against the Kubernetes APIs and access the Kubernetes resources. So it is sort of the same process, the same thinking as in the Google Cloud service accounts, in Kubernetes service accounts and Google Cloud service accounts. I have two types of service accounts, but they almost serve the same end result, controlling the access to the back-end resources. In Kubernetes, you are talking about Kubernetes service accounts while in Google Cloud, you are talking about Google Cloud resources. Cool. So what if I can automatically connect a Google Cloud Service account to Kubernetes service account so that, this is very important, so that workloads running under Kubernetes service account will have the access of the Google Cloud Service account to the Google Cloud APIs. Let me say it again here, because this is maybe the most important statement. What if I can connect Kubernetes service accounts, which are attached to Kubernetes resources such as pods, where my applications are running, so that my application will have access to that, will be attached to that Kubernetes service account. And then what if I can connect the Kubernetes service account to Google service account so that Kubernetes service account will have the same access as the Google service accounts, which dictate to what resources and what and how resources in the Google Cloud platform can be accessed. The end result is that my application on one side will be able to access the Google Cloud resources on the other side using that Google Cloud service account. Nice, right? Let me show you another example. In this diagram, as you can see here, I have my application running inside a pod. Cool. That can be any application just being deployed to the Kubernetes service. And then simply I can attach a service account to my pod or my deployment, the whole deployment, right? Or any other or many other resources inside the Kubernetes cluster. But then, because I can attach Kubernetes service account to the Google service account, I can use my application can access Google resources using that Google service account. And this is exactly what Google Workload Identity Service provides. Google Workload Identity Service can enable us to do that automatic mapping between a Google Kubernetes service account and Google Platform service account. A very neat and beautiful, well-designed solution to minimize the risk of exposing and generating service keys to the server for the service accounts to be used by the applications. As you can see here in this scenario, I'm not generating any service key. Let's say it's a keyless solution. There is no private or public keys shared. Absolutely not. I have my service account on one side, I have my service account on the Kubernetes side, I'm mapping them, and then I'm saying to the developer, in order to use that Google service account, and consume Google services, simply you need to have that service account attached to your deployment. Who's responsible for attaching it? It's up to the Kubernetes administrator to decide. But once it is attached to the application, the applications can consume Google services on the other side. Now, why this is important for for GitLab? Why this makes great sense for CI/CD automation in GitLab? To answer that question, let me describe for you or give you a very high-level description of GitLab. I like to think of GitLab as two main components. GitLab Server, which is responsible for all the user interface or GitLab portal, users authentication, authorization, source code management, and many other services. And then we have the other component, which are GitLab runners. These are the components responsible to reach out to the automation pipeline in the GitLab server, in GitLab projects, pull jobs from there, the automation jobs, and basically execute them. These runners can have different flavors, executors. They can run as Kubernetes pods, they can run as Docker machines, they can run as Docker, or they can even run inside a machine directly using the shell executor. So in this session, let's focus on that Kubernetes runner. And remember, this is a native out-of-the-box Kubernetes our GitLab capability, GitLab runner capability. Doesn't require any third party or any customization. Basically, we provide the Helm chart to deploy GitLab runner inside Kubernetes cluster. So let's put here everything together, right? I have my GitLab automation pipeline, consists of, in this case, 4 stages. They can be named anything. In my case, they are build, test, staging, and production. And it has 5 different jobs: build, test 1, test 2, the auto deploy, and deploy to production. Each one of these jobs will be pulled, as I said before, will be pulled and executed as a job in one of the attached runners, right? So in my case, I can have my runners running as pods inside the Kubernetes cluster using Kubernetes executor for the runner. And I think now you can see where I'm going. Now, that job will be running as pod inside with the runner inside the Kubernetes cluster. Now, that runner is a typical workload similar to the application one we saw before, so that I can attach a service account to that runner, to my job, which is executing my job. And then, because I am using Google Workload Identity in the background, I can attach that Kubernetes service account to the Google service account, and map them together. Then my runner then can consume the Google services based on the roles attached to that Google service account. The end result, you see that job, let's say built in the top here at the top. I can run inside, and I'll show you that in the demo. I can run there a Google Cloud CLI command where I am consuming Google Cloud services directly without doing any authentication, because the authentication is done for me already when I am running inside the runner based on the Kubernetes service account, which is attached to the Google service account. So I call this the beauty of both worlds: GitLab Kubernetes executor and Google streamlined, very well built security solution where I'm using workload identity to attach to the Google service account, and then I'm using Google identity and access management roles to decide what that service account can do and to which resources in the cloud. A very neat solution. Now, to do so, how can I configure this environment? You may think that the configuration is sophisticated or advanced. It's very straightforward, really. There are 2 things in here I need to configure, or 2 levels: on the Google Cloud side, and then to consume that in GitLab runner side. In the Google Cloud side, only 2 steps here. First, I need to use the Google Cloud CLI to create an identity and access management policy binding, which would bind or grant the Kubernetes service account access to act as the associated Google Cloud service account. Right? Easy. Basically, I'm granting this Kubernetes service account access to that Google service account. First. Second one is a very straightforward one. Using the kubectl, Kubernetes CLI command, I need to annotate my Kubernetes service account with the name of the Google service account it will act as. I think it makes total sense. Map them, bind them, and annotate. Bind and annotate. That's it. Second one, done. This is workload identity. And by the way, Google provides a very well-built documentation on how to configure Google Workload Identity. Please feel free, and I'll show you the links to that towards the end. Please feel free to review them. Second one is from now I have a Kubernetes service account mapped to a Google service account. Then now all what I need to do is to tell my runners inside the Kubernetes that please use that service account. To do so, first, GitLab provides the Helm chart to deploy GitLab runners inside the Kubernetes. Part of that, we provide the values.yaml file, which will be passed into that Helm chart deployment. In that, all that you need to add two environment variables, one optional and one mandatory. The optional one is the first one there, which is Kubernetes service account override. Now, the beauty here is that not only I can have my application, my jobs running inside the Kubernetes service account and be automatically mapped to the default service account for my runner, I can, if I decide to, of course, I can provide my runners with the ability, or my jobs, sorry, with the ability to decide which runner, which Kubernetes service accounts. Imagine that you have multiple Kubernetes service accounts mapped to different GitLab, Google service accounts. I can give the jobs the flexibility, or my code the flexibility to decide which Kubernetes service account I want to use in my job. Right? Easy. I can do that. And then it is like a menu. Service account, Kubernetes service account 1, map to Google service account 1, 2, 2, 3, 3, and so on and so forth. That's done using that first environment variable, Kubernetes service account override allowed. Override the default service account attached to the runner and enable CI/CD jobs to use other Kubernetes service account. The second one there is the mandatory one, which is which Kubernetes service account you want your runner to be using by default. Simple. That's the one where it will be used by all by the deployed runner and will be used by all the jobs running inside that runner, that service account, which is the one in the previous step. In the previous step, I mapped to the Google service account. I hope it makes sense. And then simply you deploy that runner. Well, these are some online references if you like to for further reading on Google workload identity and how it can be configured inside the G-key, and actually it can be configured on inside all the other Kubernetes flavored services in the Google platform, and also the link to how to deploy GitLab runners using the Helm chart. Now, let me switch quickly to the demo and show you something, show you this in action. Basically, this is a project I have where I am trying to consume and deploy my code to the Cloud Run in Google Cloud. I'll show you the typical way, the normal way, and then I'll show you the optimized way. This is how generally we would have do it if I didn't have the workload identity from Google configured. Basically, I have my credentials private key stored as a private key inside GitLab, which is, if I go here, I'll show you how to do that. So inside GitLab, I can go under variables and define my private keys or secrets here. And this is the one I have where I have my private key, right? Good. And then what I'm doing here is I'm doing the authentication part, and then basically I have my token then generated, and then I'm calling using the gcloud CLI. I'm doing the submit, the build, and deploy to the Google Cloud. Cool, excellent, very straightforward. As I said before, the main risk here is that what if this key is for somehow got leaked, mispositioned, misplaced, whatever. And this takes us to the more optimized way. So this pipeline would run, but then the the better way of doing it is I have it here in this branch, where I don't need this authentication anymore. Done. I don't need this step to be done at all. All that I need to do really is in my job, it's the same exact job. The only difference here is I am using tagging. In GitLab, I can use tag to attach job to a runner. That runner is the one I configured. The runner with this tag is the one I configured in the background with the Kubernetes service account, which is attached to the Google service account. Remember this thing. And by the way, I'm using, I deployed that runner using GitLab provided Helm charts, but also what you can do is GitLab provides what we call GitLab Cluster Management Sample Project, which please feel free to use it. It's here in the documentation. Just GitLab Cluster Management, where it's a template project where you can import and use to deploy runners using Helm charts and deploy many other services to the Kubernetes cluster. So in my case, if I show you, this is my GitLab cluster imported project, and this is the Helm file or the values file for my Helm. Two main things here. These are the two variables I showed you before, and this is what the name of the service account I am using, the Kubernetes service account. And then these are the tags. I'm tagging my runner. And as you can see here, this tag match the tag on the job I'm using in this instance. So basically, Mr. Job, please you need to be pulled only by that runner with that tag, and that runner has the service account, Kubernetes service account attached, which is mapped using workload identity to the Google service account, which dictates how I can use my cloud services. So if I go here now in the pipeline and run my service, run my pipeline, and this time I will run my pipeline using the workload identity and run my pipeline, then you'll see that it will be pulled basically by that runner at the top. And now it is running using the Kubernetes runner inside my provided namespace. And now it's doing that in the background. So while it is running, just to summarize, what I've described here today is that how can we minimize the risk of creating, sharing, and over or misusing security keys while authenticating to the Google Cloud platform. Usually, to use Google Cloud as a non-human user, I need service account. In order to avoid creating security keys for every or multiple security keys for these service accounts and share them with the developers to run their CI/CD jobs, as we saw here. Basically, I used workload identity to map the Kubernetes service account in my Kubernetes cluster to the Google service account. And then all what I have done, second step, is I deployed my GitLab runner inside the Kubernetes service account, and I dictated or I specified which Kubernetes service account to be used for that GitLab runner. There, I mapped my job, my CI/CD job, to use that runner, right? And by that, the job will be using the service account attached to that runner, which is mapped to the Google service account, and so on and so forth. So as you can see here, I could now use directly call the Google Cloud build command, which is up here, up, the Google Cloud build submit command, without using any secret key or without using the activation command in my code. I hope that all makes sense to you, and it shows you the value of having or using workload identity with GitLab CI/CD jobs to automate and secure your execution. I really hope you enjoyed this session today, and looking forward to seeing you in more sessions in the future. Again, my name is Samar Akub. I'm a GitLab Channels and Solutions Architect. Thank you very much for watching, and thank you for your time on this session. Goodbye.